Hey, hello everyone. Thank you for attending this seminar course. AI for scientific discovery. So this week we will invite students to do presentation on AI for math. Before that, I would like to briefly mention the next step plan, which is the main course of this, the main concept of this seminar course, which is give you some initial practice of how to do research. So the which will be some evaluation. Don't worry, if you do it, then you will get 2 points. So this will be the midterm and the final evaluation of this course. So it will be a small project, the project that you lead. And then you are going to pitch it, and then you are going to summarize it with some a short presentation and also a paragraph in PDF. So what should be contained in your project? First of all, you are going to identify some problem that you find is interesting, and you find that there are some uh, problem, like research problem that you find. For example, you can pick up a paper, recent, like published last week or last year, and then you find the paper is still lacking. And you tell us the audience, and then you describe it in your PDF, like what is the unsolved problem. And then you just try to like sketch, try to solve it. So how to solve it? Then you can have some hypothesis. Like I think the problem can be solved in this way or in the other way, in whatever. And then what is your expectation after solving this problem? What good result can happen? So one of the ways that you can formalize your research or formalize your submission is following some existing method. So there is a like in the existing research, there is a template that we can use called Helmer mechanism. So basically, it was asked DARPA. So basically, this guy, George Helmer, he is a former DARPA director from 1975, and then he was a kind guy, and then he find out there are a lot of unsuccessful proposals, and then the proposal was rejected for a lot of reasons. So he started a several questions and then several templates for you to better pitch your research. So the set of questions he created, it called the Helmer mechanism to help you before you submit a proposal, and also help the agency official to think through and evaluate the proposal. So basically, the process is your advisor try to pitch an important problem and then describe it in a proposal, and it will be evaluated by the government. And then the government officer is going to decide whether to give you money or not. So if you got the money, then you can buy a lot of expensive GPU, and then invite student money to do research. It's a good thing. But the funding rate is low, so only few of the proposals got funded. And then he figures out a template before, and then you can evaluate how important your research. First of all, what are you trying to solve? What is the topic you are trying to attack? And it should be some clear objective. You should not, like, when you read the paper, you will learn a lot of new words. And then the new words create, maybe you understand it, but you should describe your objective in clear language. You should not contain a lot of jargon. And then the second problem is how it is done today, and what are the limitations of current practice. So like if you're studying the problem like 100 years ago or 10 years ago, and maybe it's been solved, maybe it's no longer important. So we wanted to know, like, by today, is there still a big gap? Is there still some limitation, different aspects of the limitations that is still lacking? And then And then you have your smart idea, and then you have your beautiful brain, and then you think that, oh, I have a way to solve it. And so that, what is the new, like, what are the tools that you are offering in this community or in this product that you think that will be successful? So you can have such guesses. The nice thing is you can have a solid guess. As long as one of them is successful, you can finally correct. But here you are going to conjecture some way that you are going to operate some boosting. And then is like, what is your audience? Like, if you are successful, what difference we will make? So who cares is basically if you are submitting some proposal to the correct agency, then they care about specific topic. Different agencies have different interests. So when you submit to like DARPA, maybe you'll be more relevant to national security or whatever. The second question is, if I use your beautiful tool, if I use your advanced software, then what is the better result I can get? And then can you describe it like either in experiment, I get an improved number, or either in theory, so like theoretically thinking, if all losing happen, then I can get like a better bond, like I can better describe it or whatever. And now you want to develop your tool. So does it cost a lot of money? You need to to decide like, do I really need a 3 years time period to solve this problem? Or it will need me like a month to quickly verify. So this is very important before you doing a project, you need to calculate the amount of time, the amount of people, and then the difficulty. So, which is what is the risk? Like, do you need to learn everything from you? And then how long does it will take? Does it mean that I need to bring a student with no background and then carry that student with you to learn everything from scratch? These are all the investment you are going to pay. And then the last part is very hard, and then most of the time is missing. So so you have some conjecture about solving a problem. And then how do I know you did it? And then how do I know that the minimum that you did? So you need to give yourself some kind of short milestone that you can know that if I can reach the easiest goal, then it shows that I can keep working. So there are a lot of problems that are not able to be solved, either by the limitation of the current AI community, or by the limitation of your knowledge. You need to learn a lot of concept, or by a lot of like it's a lot of hardware. You simply do not have a lot of GPU. So before you like directly like download some code and then play with the data, you can easily check in the bare minimum setting. If I have a very small neural network, whatever, can I like check whether my new component in the easiest setting is doing the good thing or is completely not working? So here's like just another way to formalize it. First of all, the first in your pitch, you should tell the audience in clear language what is the problem that you want to consider. Like I want to consider like as large language model to solve more mathematical problem. Asking the large language model to solve mathematical problems that can so that and I can check the reasoning step how the AI is going to understand and solve the mathematical problem. And then the problem is important because it is will be beneficial to a lot of audience, or the problem has been attacked by the community for so many years to provide a reason why this problem is important. So the problem is by us answering this question, you will realize a certain part of the problem or certain part of research is incremental and should not be funded. You should not put like 3 years or many years, a lot of resources on those research projects that do not give you a lot of return. So if you have 3 years, and then you can do like, for example, one project, you want to do those important problems because this can lead you some like return. For example, you will have a oral presentation at those important conferences. People will know you, or maybe you will publish your first top-tier journal or top-tier conferences. If you are like working on some incremental or not so important area, people would just feel like, oh yeah, it's just yet another application. Yeah, we solved the problem, great. And people do not have much impression, and people do not think you are genius. So when you're looking for a job, when you're looking for an internship, and then people just feel like, yeah, you are diligent. And then that's basic comment they will tell, but they will not thinking in a way that you identify important problems that everybody care about. And then you have a way to attack it. So that most of the time people feel like that, are you working on important problem or are you working on some trivial problem? And then the second sentence is usually it will require you to read some existing paper. So basically, historically, A, B, and C has been used to attack it. Now, this is the time that once you identify some problem, or you read a paper, and usually you will find it in the related work section, which is saying that many people, like from this group try to solve the problem following this track. The other group try to follow the problem in this track. For example, in the math problem, classic people try to using a lot of smart search algorithm, pure search, try to in the space of the whole group, they try to search and then they try to design a better search algorithm. Recently, people try to design some AI algorithm to directly predict the result, and then with some like textual-based description. So now you'll find that different people they have a lot of improvement. They form into group. Now it tells people that a lot of effort that we try, but there's still one problem cannot be solved. So which this will be your third language, third sentence. However, there are still fundamental difficulty, which is saying that you are so important and you are so smart that you identify a big stone in front of everybody. And this is the kind of true point. If you identify a problem that only exists in one paper, and then you fix it, and the other guy is relatively more powerful, you find a common pattern between A, B, and C group of people, they are all like it. So without even looking at the experiment, people has already had their like impression. Are you solving a important problem? You are fixing a problem that only exists in that specific setting, or you are solving a problem that can exist here and here and here. So this is one of the settings that you will realize how many people will like it. If you're solving a problem that only exists in one paper, only the original author of that paper will like it, because you solve this problem. If you are solving a problem that exists in many research community, once the people has experience working on that interaction, they sort of know that, oh, the problem you find that is not trivial, and then you are solving it. So you will have 3 group of people reviewing your paper, and each of them find that, oh, you are solving the problem that I cannot solve. So I think it's a good research. This is saying that without even looking at how you are going to solve it, without looking at how your experiment is executed, you are solving some non-trivial problem. So this is the most of the time that people feel frustrated, because people will do research in a reverse way. You will read a paper and then download the code, play with the data, and then try to look at the existing subproblem that they can identify. And then they try to fix it. So after several months of attack, then they find that, oh, they had some way, and then they formalize it. But research when people actually read a paper, they read from the other direction. So you do a research from bottom up, people read your research from top up. Now people find that what is the problem that you are solving? This sentence will only be answered by the last day of your conference cycle. So the student will come up, try to like summarize that research, saying that, oh, why my experiment got better? Can I just like describe what is the existing problem? Most of the time you couldn't, because we have one day. Think about it. The other guys then has already have some like problem in mind. What is the problem that I can attack? You can have 10 difficulties. As long as one of them is easy to attack, you attack it, and tell everybody, I'm solving a non-trivial problem, and then the problem you describe. So if you have one of the conjecture about limitation, and then you tell about the limitation that actually a common limitation that exists in group A, group B, and group C. So they all share the common limitation. Now you feel like the human cannot breathe, and then the world will never see tomorrow by having this limitation. So you are going to describe what that result can happen. For example, if you ask large language model to solve a mathematical problem, then it can be, if you ask it to solve a hard problem from a certain state, all the follow-up is incorrect. And then it also can be all the derivation is incorrect. Somehow the final result is correct. So the whole proof of large language model is make bullshit, and then it's not trustworthy. You cannot just like if you have like a kind kid in the kindergarten, he wants to ask you, Dad, can you help me to solve, or Mom, can you help me to solve this mathematical problem? And he said, I'm busy. So you give your ChatGPT account to that your kid, and then kids play with it, and then kids somehow learn math in an incorrect way. And then yes, go ahead.
Yeah, so a quick question. Then because of this limitation is for all three, or it could be like because of limitation A, this can happen, then because of limitation B, this can happen, or should it be like globally?
You can think of it like the limitation of A, which is saying that A will try to attack the problem in this way, and then you can analyze break it. Okay. And then this is the more bad language. Yeah. What would the bad result will happen? Okay. So for example, for example, we just talked about that if it's a search method, then for harder and harder problem, you need way more exponentiated time to solve it. So you need to wait weeks to solve some hard problem. And it cannot be applicable. So scalability is the issue. If you ask the language model to give you some outputs, then the result is not, it is interpretable because you got some text and you can read it, but it's not trustworthy because the whole derivation can be completely wrong. And then there's no way to ensure the trustworthy. So you want to design some new mechanism. Now you propose some weapon, a new weapon. And it's most of the time you will read some paper that they will tell you they propose A plus B. Or they propose some tool in domain B and then they want to apply it in domain A. This is fine. Because this is how people create their own research. And then one thing that they could not answer is what is the fundamental difference? Like what are the new that you are bringing in? For example, it could be simply you bring a tool that, for example, you bring a lot of different mathematical software into the AI system, and then what is the new? Like, can you make it differentiable? And then can you make it like some new properties that people are looking at? Doing A plus B is something when people realize that people are just looking at what are the new properties that you can bring. If you develop some new tool like C, and then you can say that like design a new tool, and then this new tool can solve some problem. Also, people will make you feel like they design some complete new tool. But when they have that initial version, they are just trying to do A plus B, A plus C, A plus B. So using whatever they have learned, they try to combine a new version, and then the new version can sort of solve it. So you can like rewrite your software or redesign your mechanism, so it does not sound like you simply just do A plus B. Because if it's A plus B, then the Y is like wait until you today to solve it. There could be a lot of others that has been affected in using A plus B style, and then it's not successful. And then because of the difference, like what are the benefits? How you can tell that you solved the problem? You can solve the problem by having a better experimental number, better accuracy, faster running time. Well, in some like very competitive benchmark, your ranking is way better than your original model by using your code value. Or if none of them work, you just design a new data set and make sure that it is a large scale data set. So the scale, that data set reflects the fundamental limitation. And then you evaluate on that data set. Now this is the time you know that here are the data sets. I designed that synthesize the data set that talk about the fundamental problem, and then I want to test to evaluate whether the existing model can solve it or not. Now this will be I want try to write an email to every one of you about picking an appropriate time for you to spread your research, and then and you are invited to present a much shorter presentation. I tell everybody why my research is interesting, why is it important, and what is it. And later you can conjecture some way to attack it. So now we were looking at the, yeah, go ahead.
Yeah, so for the problem, we pick what's the can be any domain?
I mean, if you want. So for example, if you're already doing research with some other professor, you can just use that as an opportunity to tell everybody, like, introducing your research area. Does that solve your questions? So, when we say AI for math, what do we mean? So, here the data set that people usually use to demonstrate how powerful their algorithm. Basically, you have some AI algorithm. The AI algorithm going to read some sentences and output either the direct final result or some intermediate sequences. Let's try to read it. And then this data set was released by OpenAI in the early days. It's called the GSM 8000. It is considered to be some informal data set because the description and the evaluation was not that rigorous. So the input is just like how you will play with the ChatGPT, which is Natalia saw clips to 84 of her friendship in April. And then she saw half as many clips in May. So, and then the question is, the mathematical question is, how many clips did Natalia sell altogether in April to May? So if you, as a college level student, I think you can easily solve. Like you solve it, 48 and then half of it, which is 24. So if you sum it up, then it will be 70. It turned out that this is the simplest problem. So if the second paragraph, which will be output, and then this is the final calculation result. So the derivation is called mathematical reason. This is what actually people mean what from this specific data set, what is the reason, right? How you can tell your model is reasoning. So the reasoning is saying that you ask your model to output like Natalia sold 48 divided by 2, which will be some evaluated output. You can launch some mathematical calculator to do the calculation, which is 24 clips in May, and then Natalia sold 48 plus 22, which will be 72 clips altogether in April and May. So this is the sentence we ask ChatGPT or Llama to generate, and we call it mathematical reasoning. So the final output, so the algorithm will know you that the final output is 72. The other data set is relatively formal, so it will require a more rigorous definition. So there are many data sets. So one data set was put down mathematical data set. It called put down bench. It was released by UT Austin. So it was more formal. You need a formal way to represent your mathematical problem. And then the problem is relatively harder. Basically, it's like a high school level or undergraduate level. So this is the data set. If you can throw the original problem to the Flushbank model, you can transform it to informal, but it will be evaluated very rigorously. So reading your mathematical instance, it can be it was extracted from some competition. And then the description of the problem is, can you prove for every set that is composed of x1 to xn of n real number, there exists a non-empty subset of s of x and then an integer n such that the following equation is satisfied. So there is some existing research. Basically, people just like how you represent the program. You write a program in C, or you write a program in Java, or you write a program in Python. So there are a lot of existing interpreter trying to represent the textual description in some form of description. So if you this was invented this is called COQ. This is Lin and this is Isabel. Both of them, all of them try to represent the textual description in some form of statement. For example, maybe this is which one is easier to read? I believe this is easier. So the first line is what is the name of your mathematical data set? And then the second description is n is a mention. N is a integer, and then NPOS is saying that n should be larger than 0, and then x is some final subset of real number, and then the cardinality of x is n, so saying that there are x1 to xn in capital X. So this is an actual symbol, just like when you learn Java and when you learn Python. You learn the keyword where, for, and then if and and. So in this mathematical statement, you'll find there are some extra symbol called there exists. And then this is the subset. I think you learn it in your math course. Now it's the time to like reuse it. And then this is a non-equal, this is an empty set, and this is the logical n. So this is saying that for n plus some summation of small s in capital S. So this is the exact equation you see here. This is in say that I want to sum up all the elements in set S and then plus some n. This is the size of it. Then it is less than 1 plus n plus 1. This is easy. And then this description is saying that there exists a non-empty subset S of X. So to refer to that, this is a symbol saying that there exists, and then this is saying that subset of it, and then this is saying that I am non-empty set. So you can write it either in the language Lin or in the language of other solver. And then the proof, what is the output? The proof should be some, if you follow in this manner, it should be some rigorous line of statement, just like how you write your code. So most of the time, people try to solve the code, formal mathematical problem, and then the code generation problem in a similar way. Because it is exactly as similar to when you write your code. You write your code in your first line, second line, third line. As long as you have your final result, now there is some verifier that can check whether the first line, second line, third line is correct. Now the difficult part is there are way more data in code. there are not many data in the mathematical problem. So most of the time that because there are way fewer number of mathematicians than programmers. So that's most of the time that people find is we just do not have that many training data. So this will be some common problem, and you will find a lot of research try to collect as much data, as much synthesized data, and then this will be by far will be effective for doing this mathematical data set benchmark. Now, I just talk about some instance that people can be familiar with this domain for the AI for science problem. Now, I would like to invite Alex to talk about a pitch paper, formal mathematical reasoning and new frontier in AI. Now, let's welcome Alex.